Welcome to dilation and reflection of parent functions. Let's get started. So here's our quadratic parent function. It's a parabola. It's f of x equals x squared or y equals x squared. We know that it's our parent function. It sits here on the origin, 0, 0. Now if we saw a parabola that was a little bit narrower than the parent function, we know that it's still quadratic. It's still a parabola. It's not the parent quadratic function, but it is a quadratic function. Same thing for if we saw another graph that maybe was a little bit wider. Still quadratic, not the parent function. Even if we had a graph that was a parabola, but it was upside down, still quadratic, not the parent function. So that's what we're looking at today. We have parent functions, which we've gone over, and each parent is going to have a bunch of kids. So that's what we're going to look at, what we're going to refer to today. All these other parabolas that look like the parent function but aren't really are their kids. So right now all the parent functions that we have, y equals x squared, y equals square root of x, the square root parent function, the cubic parent function, and so forth. They all have a 1 in front of them. That is our a. So any number that's in front of that parent function is our a. And when a is 1, we just have the parent function. Now when a is greater than 1, so when we have maybe y equals 2x squared or y equals 2 square root of x, something bigger than 1, 2, 3, 4, all the way up to whatever number you can think of. That's when we're going to have a vertical stretch. What that means is if you took this quadratic parent function, so here's our parent function, and then we stretched it. We made it maybe y equals 2x squared. We would stretch it from the top, pull it up, which means that it would get narrower. It's still at the origin though, but it's just narrower or skinnier than the parent function. Now we have to say vertical stretch, because with the quadratic it does get narrower, but if you had, say, the cubic or the square root function, here's the square root function, the parent function, and you put the a greater than 1, so y equals 2 square root of x, it stretches higher. So when you stretch, it gets a little bit taller. So we can't always refer to this vertical stretch as skinnier or taller, because they're different depending on the parent function that you have. So you have to use this vocabulary, vertical stretch. When your a is greater than 1, you have a vertical stretch of your parent function. Now when our a is in between 0 and 1, that means we have a fraction. So if you want to think of it like that, any kind of fraction or decimal, less than 1, but still greater than 0. Then we have what we would call a vertical compression. So we compress that parent function. So with the example of the quadratic, here's the parent function. When you compress it, when you make it y equals, let's say, 1/2 x squared, so now our a is a fraction, or it's between 0 and 1. It gets compressed, so you're smashing or compressing this graph down, which makes, in the case of the quadratic, it makes it wider. Now remember, with the other functions, the other parent functions, you wouldn't always call them wider. That's why you have to use the vertical compression phrase. So when a is between 0 and 1, or fraction, we have a vertical compression of the parent function. Now, the last thing is when a is negative, when it's a negative number. So I'm going to work with the square root parent function. So here is y equals the square root of x. There it is. And when we have a negative, y equals negative square root of x, it just reflects over the x-axis. Now, the negative, it doesn't matter what number it is. If it's y equals negative 2 square root of x, well, the 2 is going to tell us we have a vertical stretch, and the negative sign is going to tell us that it reflects. So it will be both. We'll have a stretch and it will reflect. So remember, it doesn't matter if your a is greater than 1, if it's a fraction, or if it is 1. The only thing that this negative sign tells you is that it reflects over the x-axis. You still are looking at a is this number right here. This tells us it's a stretch, this tells us it's a compression, but then the addition of the negative tells us that it reflects. So here's a quick summary over what we just went over. When a is equal to 1, and I'll write this here just in case you forget, your a is just the number in front of that parent function. So whatever your parent function happens to be, it's just the number in front of it. So when a is equal to 1, you have the parent function. When a is greater than 1, that's when you have that vertical stretch. Remember, you have to use vertical stretch, not narrower, skinnier, because it doesn't refer to all the parent functions. When a is in between 0 and 1, so when it's a fraction, you have a vertical compression. You compress that parent function down. And if a is negative, that just tells us that it reflects, the parent function reflects over that x-axis. That's it for this week. Thanks for watching and see you soon.